Getting closer to that number, so let's see if it pops the alert.
22.1 volts.
There you go.
1, 2, 3, go!
Good morning. Okay, in today's video I'm gonna show you one of the sensors from RadioMaster for PWM receivers. In this case we are talking about the RadioMaster ERS-CV01, which is basically a battery sensor that connects directly to your balancer port, and then it goes directly with the cable to your UART port from your receiver over there. Very useful, very easy to use. Still is not fully plug and play, but I'm gonna leave you all the steps that you need to do to make it work. It's simple. RadioMaster gives you a very nice and detailed video on how to install them, how to make sure that this thing is working, and more importantly, how to install the widget that you are gonna need to be able to see the voltage of each battery in your transmitter. So I'm just gonna leave you the steps. Very simple. Install 2 folders inside your transmitter, and very important that the version of your transmitter is exactly the same as your receiver. I'm going to show you with the stick cam how does it look in the air, and how we program some of the special functions to hear and to see the information transmitted by this sensor.
Welcome to Edge TX.
My transmitter, volume up, and I've configured my voltages to be here. So as you can see now, it's no cells detected. So I just wanted to show you the whole process. I connect this little cable here to the UART port of my receiver, and then I'll connect it to my balance port. So you will have like a negative sign over there. That's gonna be your ground. So I connect my 6S to my battery, and you will see that there is a red LED popping up. That means that it's receiving information, not information, but voltage, of course, from the cells. After that, what we can do is connect our main battery. So our system is going to be connected. So let's give it a try. Throttle cut, activate it, and we connect our main battery.
0%, 0 volts. Telemetry connected.
And you see, now I have the green solid, and telemetry is connected from the transmitter. So I'm just going to leave it something like that. Close it. There you go. And then we can have a look on my transmitter. So I can see the 6 cells. I can see that the total percentage is 96, 25 volts, and the biggest difference between the cells is 0.0. It was 1, now 2. To show you the whole process, basically if we go to the model information, then we go to the last one, which is the sensors. At the bottom you need to see the cells. Yeah, if it's not populating there, just click on Discover New, and then it should appear. Once you have that, means that your receiver and your transmitter, they are reading to each other. So now we need to make a use of it, right? So I'm just going to show you. I really like how I have it right now here. That's how we are going to fly. But let's say that we are starting from 0 and you want to display this in your transmitter. Let's do that. You can click on your button of telemetry, and with this button what you can create is different pages in your main screen, right? So I'm going to create a new one. I'm going to add a screen. And in this one, you can adjust what is the configuration of your widgets. How do you want to present them? Let's say that we want a full screen. I'm just going to use that window only for the battery information. I go to Setup Widgets, and as you can see, I have now the full space for whatever I want. So I'm going to click, and then I can choose what I want. Normally, we would use a value to put things like RSSI or whatever. But in this case, the widget that you have installed within your folder system is the cell values. Clicking there, I can adjust now the settings, but it's important to say that the cells sensor is, and now you go into the telemetry, which is this icon here. and you look for the cells. It will appear at the bottom, and we have cells. And you have different values, right? You have the cells, which is the whole thing, and then the minimum and the maximum. I'm gonna click the general cells. And with that, now if I move between pages, I go to the next one, I can clearly see all my voltages in a different way. Of course, you're not going to be looking at the screen during the whole flight, so it's a nice thing to have. It's nice that you can put it into different sizes, different places on your pages, and distribute it as you want. But the most useful thing, in my opinion, is to hear an advice, an alert, whenever we go under certain voltage, okay? So in order to do so, we need to use two things. One is logic conditions that whenever we are below a certain value, it triggers a switch, let's say. And then a special function that whenever this logic is activated, whenever this happens, the radio does something. And this something is going to be to play a value, for example, of the voltage of the battery. So we don't only hear that there is a problem, but it tells us what exactly is the voltage of the battery. So we are in the main page. If we go to model, the last three are going to be the relevant for us, right? The last one, it indicates us all our sensors. And for the cells, as you can see, now we have a fully charged battery. We have 25 volts. So the cells sensor is going to be the one that we are going to be using. The value that we are going to be reading, it's going to be the one coming from cells. So let's start by the logics. I have it already prepared. This is my logic 22. I'm going to go to edit, and so you can see it. It's whenever A is smaller than X, trigger this logic, right? And the value is going to come from the sensor cells, and the value that I put here is 22.2. It's a very conservative number, but it's going to be our basically our nominal voltage of the battery, 3.7 times 6 cells that we have here, so 22.2 volts. Whenever we go under this value, this system is going to trigger this logic 62. So this by itself doesn't do anything, but now we have the chance to do, okay, whenever this logic is triggered, do something. And to do that, I'm going to go return. I'm going to go to the next menu, the next page here, which is the special functions. Here I have the volume, I have the brightness, I have all configured in the special functions. So if we go to the bottom, you will see that the special function 11 is linked to the logic 62. I'm going to edit, and as you will see, the logic 62, whenever it's triggered, because it's below 22.2 volts, it's going to play a value. And which value? The one that the sensor is reading, the cells, and it's going to repeat it once. Yeah, and then of course I have it enabled. So that would be it. That's the whole configuration that you need to do. So let's give it a try in flight. Remember that things are changing in competition RC aerobatics with FlyCoach and FlyCoach Score, where flights can now be analyzed and judged objectively. It is an amazing tool for training, but it's also becoming very interesting for competitions. Honestly, I doubt I would receive the same score flying my little Olympus in a real contest, but that's exactly the point. FlyCoach Score does not care about which airplane you are flying. It only measures the path you are drawing in the sky and analyzes it according to the sporting code. I recorded these flights with the SkyTracker Pro, and I'll leave you more information about the FlyCoach Score in the video description. Now, I'll leave you with the data from this RadioMaster sensor.
Getting closer to that number, so let's see if it pops the alert.
22.1 volts.
There you go. Again, very conservative. Normally in F3A I'm using more like 3.6, 3.50 something. But this is something that you need to see. Depends on the system and everything. But let's see if it triggers again. Pushing the battery for another integrated roll. More power.
22.1 volts.
Perfect.
During these first flights, I also recorded all the telemetry with my RadioMaster TX16S and checked the minimum voltage reached during each flight. This helped me determine the warning value I should use to land at around 37.5 volts. From now on, that will be approximately the threshold I will use for the alert. It also shows how easy it is to log all the telemetry received by the radio and later plot and analyze the data.